All right, this is part 2 of the iodine recycling process. Part 1 was describing the flow chart here, what I was using to rejuvenate the recycled spent solution. This is a spent solution that I had from this morning, and up here is the small amount of hydroxides, and mostly gold, I think, from this morning. And what I'm going to do is this again, some earlier, just the using an alkaline solution to strip, as opposed to an acidic solution, which you end up with this amount of junk and goop for each one of these tests. So, all right, let's get started with this here. So, we're going to take our solution off here, and not a lot. Hopefully it's all gold. That would be happy. Now the process I use is just a single filter so I don't build up a lot of waste sludge to try to process with hydrochloric later to strip out any, like this big batch of junk back there. I would hit that with hydrochloric and eliminate as much of the hydroxides, the hydrochloric acid dissolvable metals. So we got that laid in there nice with a little bit of water. Set that aside, put our solution in here for another run. Now there's a little bit that got through the filter here, but that'll go right into the next batch. So we'll get him prepped. Now in the first step here, try to do this quickly. So I'm at 400 milliliters. We're running a little high because of that wash every time. So we got 500 milliliters. I'll throw in 3.5 milliliters of formic acid. Stay away from hydrochloric because it ends up accumulating, I think, chlorine, and makes your stripping ability much poorer. So there's 2. Usually another 1.5, but we'll go another 2 this time since I'm running at 500 milliliters instead of 4. Stir. This should get us down to a pH of 2, hopefully. I should draw some purple color to it. Well, we'll flip over here and do A, which is adding some hydrogen peroxide, 12%. So if I grab my hydrogen peroxide pipette, which has been handy, this little rack, I could avoid contamination. We'll grab a couple of milliliters here. A little shy. Usually this kicks over. You check the pH. See where we're at. Oh, I forgot a step. Okay, we're continuing here. Checking the pH, and that 4 milliliters of formic acid was not enough because I got the extra liquid in there, I believe. So let's keep running down to a pH of 2. I did add hydrogen peroxide in there too, unfortunately, but let's add another 2 milliliters. Now we're getting some of our color that we would expect. Always check the pH before you run to the next step. When you get purple on here, you kind of got to watch the bleeding action as to how it So it kind of shows in the green, or you could call it even up in the maybe 4 or so. Is it 5 or is it 4? Let's add a little more so we're fully in the pH of 2. We'll add another 1.5 mils. Hopefully that gets us where we want to go. Earlier I added a little bit of hydrogen peroxide, so that would explain the orangey fizz and such. And we're starting to get a purple color now, which is good. So if I did not get a purple color, I would then go in and add, this step here of adding hydrogen peroxide, which I've already added plenty, and adding Ki, and then some hydrogen peroxide to kick it over to get a deeper purple color. But I'm happy with that. So now we raise the pH from an acid level up to a pH of 8, and to do that with 400 milliliters, it was about 2 grams of potassium hydroxide, which I think was half a scoop of this, roughly. Ooh, looks like an orange drink. Still nice and purple yet. We could use a little more yet, I think. We're still up in the 4 area. Let's try that. We're getting some green. I think we'll just stay with that. Yeah, it's always a tough one. I guess you're supposed to mix this 10 to 1 and then measure it, but we're going to run with this. Now we need some gold to throw in. All right, found ourselves 200 grams of gold-plated pins. That should do nicely. Stir constantly. So we'll start seeing this color fade a bit from our nice purple color into a dark tea color. Then we got to make a decision what we're going to do. If we're going to end it and grab the gold, or if we're going to cycle back and make it more acidic and put in more free iodide or not. I'll cut this here now and shoot back when this looks like it's been stripped a little more. Well, I've been poking at this for about a minute or two. It almost seems like there is some stripping going on here. Seems to be fading. And back for another pause. Okay, it's been another couple of minutes, and you notice the color has faded from my nice happy purple color to dark tea or a brownish color. So let's hop this stuff up a little bit. Instead of going all the way back up to an acid and creating a bunch of iodine, let's try a little bit of hydrogen peroxide and see if we can spice this up. Earlier when I tried this, it actually it went clear color, but the thing seemed to be actually cutting. We'll go with the milliliter here first. Oh, look at there. We definitely lost a lot of gold color in there. And we're definitely cutting copper also because of the green color, I guess. Look at that. I'm going to get a pH number on this. This is rather interesting. Well, green is the majority of it, but that's the color of the liquid, and up above it is kind of a real faint area. It could be a 5. You guys can decide. Man, a lot of that went away. There's still gold in there, but a lot of it is gone. Let's move forward with this process and just see where we're at. So we got our filter in here. I'm getting a little ahead of myself here. We got to drop everything with KOH. But look at that. Wow. That circuit board, that could be a copper color. Almost looks gold. Look at that. That's not bad. All right, let's rinse him out just a bit. Okay, time to drop the gold. I think I need about 2 scoops of this, probably a little more with the 500 milliliter. Oh, actually, we're not going from all the way acid. We're going from 8 up to 13, so I may have added too much of the potassium hydroxide, but we'll see. Stir rod. If we start getting a flock development, we'll know we're there. I may have been a little lower pH than I wanted and picked up more base metals than wanted to have. So I think I'll let this sit for about 3 or 4 minutes and then go in and filter it. Going on pause. Okay, you can kind of see the flocking material in there. It's set for about 3 minutes, and actually I put in another half a scoop of the potassium hydroxide just to make sure I'm fully basic. So let me show you the method I've been using to filter this stuff and minimize the amount of filters that I have to run. Of course, the more filters, the bigger filters, it just makes more junk when you got to deal with it after you try to process it. You collect all your filters and you extract the gold as the final step. So what I do is I set my vacuum pump so I can bleed off vacuum right here with this control. So I put it way down and low, and my idea, or my process, is to slowly add filter material by putting this material through it, and it'll slowly plug itself up. First, you know, a lot of the material, the hydroxides, will go right through the filter, but as it runs, it will plug the filter and form a better filter to catch the stuff that's in there. So you can see I did throw some blue material through, and as it pumps, it should start clearing up, and I think it's getting clear enough here where I can start cranking up the vacuum. So as I increase the vacuum here, just slowly, working on up, and I can get to the point where it will do a really nice job of filtering out the junk, and I can get clear liquid through it without waiting too long. So anyway, I call it filter management, I guess. So here we are, getting a mostly clear solution coming through. And if there's gold in there, a lot of times it'll go right through the filter for the most part. And you'll end up with this black, cloudy, colloidal stuff. But that's okay, we'll get it the next time through. Yeah, you can see I've got my filter. The earlier stuff has kind of formed its own filter on top of the paper filter. Try to pour in the clear stuff as much as you can. So we're not doing too bad. Get back with here in a bit. I switched over to a new beaker, which is kind of a nice way to do it as well, because that first slug that goes through and making your filter nice and efficient. Once you get into past that, to the point where it clears up like this, and you switch over to another beaker and then dump this one in here. So I'll be back. While we're waiting here, I may as well look at these pins. Did a pretty amazing job. I'm surprised. Okay, while I'm waiting for this thing, this was last batch, and this weighs 0.28 grams. Just I tear it off the container, but 0.28 is the filter and the dried powder from the last run, and a prior run, which was acidic, where I dissolved a lot of base metals. This weighs 16 grams. Now granted, it's still wet, but that's the kind of hydroxide you want to eliminate and not strip when you're stripping with that acidic type of iodine solution. That's like a 58 times this mass is what all this goop is. So If the alkaline stripping's a little bit slower, that's okay. It's well worth not having to deal with all the material. And while I'm here, the using just a single piece of paper is much better than this frit glass filter, which I used at one point. But it would take a while to get it loaded up, so it would do a proper job of filtering. I can do that same function with a single piece of paper. I don't have to worry about scratching the top of the frit glass. So this basic filter funnel works great. Single piece of paper, coffee filter for doing the filtering. Just learn how to load it up, let a little bit of crud run through with a low pressure on or low vacuum on your vacuum, and then shut off your vacuum, switch over to another one. Always have two of the same filter flask. Switch over to a new one once you get a nice clear flow, and that's what you can get. And here's the stuff that goes in this junk. Notice a nice brown color in there, most likely gold. While I'm here, you may have noticed this crazy thing. Filler pipette, or pipette filler. This thing's great for doing small amounts of, it's a 10 milliliter pipette, but it's great for extracting a solution. You squeeze it either here to release the bulb or put a vacuum on the bulb, and if you want to draw something up, you just squeeze here and it'll draw up into the pipette whatever milliliters you want. And then once you get your milliliters in there, if you want to drain off a little bit, you squeeze this extra one out here on the end, and this will allow air to come in here and down and drain out drip by drip. So you can pre-charge the bulb with a vacuum, suck up liquids by squeezing that. Once you have your liquid, squeeze here to drain down the liquid out of the tube. So handy little device. And another little tidbit, if you're trying to make your own fume hood, get yourself one of these cheapy squirrel cage, or not squirrel cage, but a motor with a baffle and then a blower and a separate mechanism. So the air doesn't go through the motor. Hydrochloric acid will destroy your electrical, of course, if you try to run it with the motor in the airflow path. So, but this one has a baffle between the two, and it just has a simple, maybe an inch and a quarter suction on the lower end here for sucking up. And then my light arrangement, oh no, there we go, calibrated. Just a 4-foot light with a slot on the top to allow light to get in. And that's the whole operation right there. Cheapy. Okay, we just finished up the drying process here, or the filtering process. We've got a nice clear liquid to it. We'll drag this filter out of here. Try to mop up the rest here. Oh yeah. And let's get a weight on it. These are about 8 grams. Tare it. Okay, the one we just pulled off the cooker is 2.2 grams. 2 of these batches from earlier is 2.2 grams also. And all 3 of those were with alkaline. This is with acid. And this is 16.2 grams. So, yeah, acid's not the way to go. Versus this guy here. So, it's got a nice brownish color to it. Blackish, actually. These are kind of brown. So, anyway, that concludes the trial. Hope you enjoyed it.